Welcome to the production site of the Fereks plant in the village of Stalbishi. Fereks Trading House is one of the largest manufacturers of LED lamps in Russia. The company's production facilities are located on two sites with a total capacity of over 20,000 square meters. The production localization level is 85%. The Fereks plant has two design and engineering departments, employing highly qualified engineers working in the pro-engineer end-to-end design system. Our own lighting laboratory houses a goniophotometer unit which enables to measure light distribution force of all manufactured products and generate IES files for them. Up to 50,000 production units are manufactured monthly under the Fereks brand. There are several hundred modifications of multi-purpose LED luminaires. Since 2002, our company has been engaged in manufacturing metal cases of different complexity, as well as production of metal structures for telecommunication needs. Boxes, floor-specific and entrance boxes, vandal-proof cabinets, cross-connect equipment and many others. In 2010, it was decided to start production of metal housings for LED luminaires, and in early 2011, the first serial Fereks LED luminaire was released. The plant facilities include a cutting section where feature blanks for our luminaires appear from a sheet metal varying from 0.5 to 12 mm thick. Visual control of sheet metal acceptance is carried out by the quality control department. Metal cutting is carried out by CNC machine tools, such as Kimle fiber optic laser with a linear drives providing fast and efficient various shapes cutting of sheet metal. Cutting area is 1,500 to 3,000 mm. Such complex configuration parts as brackets, adapters, boxes, and many others are cut from 0.5 to 12 mm thick steel, stainless steel and aluminium at a rate of up to 48 meters per minute. CNC combined punching press by thin power with angle shears with an automatic sheet metal loading system and allowing punching with a molding tool. Working area is 1,500 to 3,000 mm. The press has high speed of parts processing thanks to angle cutting shears and the revolver for 24 tools. It is used for manufacturing panels and custom cases for office and decorative lamps. Combined punching press Traumatic 5000 rotation is a flexible machine workstation. In addition to piercing and punching, it can perform a wide variety of molding operations. It has a high speed of perforation processing on sheet metal, 1,800 strokes per minute. It is the fastest sheet metal molding machine. CNC water jet cutting machine allows for cutting parts of any geometrical complexity, including such materials as a polycarbonate, acrylic, rubber, and many more. This unit, located at the plant, allows to manufacture polycarbonate and acrylic diffusers varying from 2 to 5 mm thick for a certain series of street, industrial, and public utility luminaires. The longitudinal and cross-cutting unit allows for cutting the certain width and length sheet metal from strips for the optimal layout of the part with a high, more than 90% material utilization rate, which ensures fast processing. 2 people make 2 tons of sheet steel per shift and less losses owing to the decrease in the production waste. Amada, Salvanini and Trumpf bending machines. The bending process is carried out according to a draft developed at the design and engineering department of the plant. The Amada machine is designed for bending metal sheets and strips of various length. The Salvanini bending machine produces sheet metal panels by making a series of bends on each of the 4 sides without human intervention. 500 pieces of the same quality per shift. The maximum size of the incoming cutting sheet is a 2,000 to 1,500 mm, thickness is up to 2 mm. Trumpf bending machine, which is able to bend parts up to 4 meters, is one of the latest machines delivered to the plant. This allows us to produce one-piece decorative luminaires of up to 4 meters long. There is an active bumping system to get the perfect blank drift. Control over the quality of work performed is carried out by the machine operator by checking the overall dimensions according to the design documentation using a caliper and a protractor with automatic correction of programs on the machine via Bluetooth, as well as additional control on the part of the quality control department. Argon welding and laser welding section. Argon welding enables to weld aluminium parts. Laser welding is used to weld parts with a minimum seam thickness, which facilitates further processing and increases production efficiency by increasing the speed of welding. One of the stages in parts manufacturing is painting, which is carried out in the paint shop using through-feed painting complex. It employs a powder painting type. To date, an automatic line has been installed to prepare surfaces of the parts for painting. The assembly section for the office luminaires is divided into two parts. The first part is the manufacturing of housing components, and the second part is the assembly itself, run-through and packaging of finished luminaires. In the first part of the section, we manufacture diffusers for office luminaires by extrusion from polystyrene or polymethyl methacrylate. We also manufacture housing parts on a diaper automated line, a patented Spanish equipment which was developed and manufactured specifically for our needs. The productivity of this line, if we consider square-shaped office luminaires, is 5 pieces per minute. As for rectangular-shaped corridor or school luminaires, productivity rate is 4 pieces per minute. The high processing rate of our parts is achieved thanks to the use of strip already pre-cut, having certain width dimensions. Technological holes are machined using press molds. This enables to make several technological holes at once in one blow. Further, the cutting process goes along the conveyor belt. The final stage is bending and welding. Cold welding or molding of metal against metal using a puncheon and a die means a process when one wall thickness presses the other wall thickness and is rolled on the other side. In the second part, we directly assemble the office luminaires. The assembly of the conveyor type is carried out manually. Housing parts move along the conveyor, a certain number of people depending on the complexity of the operation. 1 person or 2 persons are assigned to each operation. When housing parts move along the conveyor, each assembler takes the housing and performs one or another operation. The main operations are mounting the board, mounting the power source, electrical wiring and closing the luminaire itself. The 100% of the assembled luminaires go to the run-through section, where they are actually run. The run-through is carried out in 3 main modes. Mode 1 is 176 volts, Mode 2 is 220 volts, Mode 3 is 264 volts. The run-through process works the following way. The luminaires are run first in Mode 1 for 2 minutes, then are turned off for 30 seconds, then switched on to another mode and are run for 2 minutes, then turned off for 30 seconds and again switched on to the third mode. And thus, the run-through cycle takes 3 hours of continuous work. Thus, we can check the operability of the luminaires directly at our factory at the assembly section. According to the application received at the production site, our print shop prints label of the relevant type. The label is unique. It contains a serial number as well as the characteristics of our luminaire. The label is attached to the body of the luminaire so that it can be identified. Then it is scanned, and with the help of a printer, the accompanying labels are printed in 2 copies. One is attached to a certificate. The certificate is stamped by the Quality Control Department after visual inspection and control of the availability of all components in the package according to the specification. The second label is attached to the box so that we can identify the shipment destination. This is the foundry section. Here we perform the aluminum die casting process. There are 4 units of equipment available, which differ in pressure force. The first is 160 tons of force, the second is 400 tons of force, and 2 machines are 900 tons of force. All housing parts for these luminaires are manufactured in this area. One or another machine is selected depending on the complexity, dimensions and size of the part itself. The principle of operation is the same for all machines. Therefore, I will tell the operation principle of one of the machines. First, the press mold is hung out. The press mold consists of 2 parts. One part is movable, the other is fixed. When 2 parts of the press mold are joined together, a space which occurs must be filled with a liquid aluminium. Aluminium is delivered to us in the form of ingots. Ingots are loaded into the crucible preheated to 700 or 800 degrees. Each machine has 4 robots. The first robot is loading liquid aluminium with a bucket into the loading device of the injection molding machine. The second robot is the rod itself, which sets the force up to the number of tons to which this or another machine is set. A certain holding time is set for the aluminium to solidify. Then the mold is opened and finished part is obtained. The third robot takes its turn. It captures the finished part and throws it onto the conveyor, where it is cooled. Then the fourth robot starts. It lubricates and cools the press mold itself. Injection molding machines are configured with the programs written by the technological department. All modes are loaded into the control module of the injection molding machine, where the main parameters are monitored and quality of the first part is checked by the operator, the compliance with the design documentation by the technical control staff. After starting a batch, the parts from each batch are checked depending on a number of details in the batch. If the batch is large and the part is very complex, we may check the 10th, 50th and 100th piece. If the part is not very complicated, quality control may undergo the 100th, 200th and 500th part. An integral part of the preparation of products for painting is the shot blasting machine. The shot blasting machine fulfills three main functions. The first is surface hardening of the metal. The second is removal of small burrs. The third one is making a sort of rough surface in order to improve the adhesion of paint to the part. To achieve it, we provide good coverage that doesn't deteriorate and fold over the time. We're now at the turning and milling section. Here, there are 7 milling machines and 2 lathe machines performing such operations like drilling holes, tapping, milling, as well as 3D prototyping of parts from aluminum ingots. All machines are digitally controlled. The design and engineering department is involved in writing programs. Part control is carried out at each stage. The first check is performed by the operator when setting up the equipment. The second is the control of the first part by the technical control department. And further control is performed at the stage of production of all parts. The parts are inspected for compliance with design documentation and key elements such as overall dimensions, threading depth and milling. All parts from the turning to milling section go to the section for preparing parts for painting and performing the painting operations. First of all, the parts are grinded and cleaned in order to remove burrs on the surface of the part. Further, the part goes to the mechanic assembly locksmiths to protect all technological holes from paint getting into the threaded connections. Next, the part is sent for painting, where all parts are painted with a powder paint. Next, the part is placed in a polymerization oven, where the paint is polymerized at a temperature of 180 to 200 degrees in about 30 minutes, and the part comes out finished. The tool department consists of 4 sections. The first is the mechanical section, the second is the erosional section, the third is the heat treatment section, and the fourth is the tool section, where we are now. Assembly, disassembly of press molds, their maintenance, major and minor repairs, urgent repairs are carried out in the tool area. All elements of press molds go to this section, and here the assembly is carried out according to the technical documentation developed by the design and engineering department, in compliance with the indicated main stages. During the final assembly, an employee of the quality control department checks for compliance with all parameters, and a certificate is issued for the press mold, where the technical control department affixes its seal, and this press mold is sent to the foundry section for manufacturing of certain parts. All fittings for operation of turning and milling machines used for processing of the parts are manufactured in the tool department, as well as all press molds used for manufacturing of the parts in the lamps production. In the mechanical section, the elements of the press molds are turned on the Mazak milling machine, which provides accuracy of up to 100th of a micron. This means 4 zeros after the decimal point. It allows us to machine the elements precisely to make high-quality parts. The machining process is carried out by the cutters, drills and taps using a special program, which is loaded into the control module itself, and all modes are set in compliance with the design technological documentation. Not all press mold elements can be machined mechanically, so they are delivered to the erosion section. Here there are 2 copying electrode machines and 1 wire erosion machine. The process of burning the elements of press molds requires making an electrode. The electrode is turned on a milling machine. It can be either copper or graphite. After that, the electrode is installed in the upper part of the erosion equipment, and the press mold element itself is installed in the lower part. The burning process is carried out. It is very long and depends on the complexity of the part. For example, here I have an electrode in my hands. It is copper and cannot be turned on a milling machine. Therefore, we have cut our Fereks logo using a wire erosion machine. This was necessary in order to burn our logo on the counterpart. For example, like this. For burning out of this logo, the electrode is installed in the upper part. The press mold element itself is installed in the lower part, and the burning process is performed. It is burned until we get the required surface. It is performed evenly with the progressive movements. It turns out that the electrode goes into the press mold element itself, and we burn out our logo. This mark is then installed in the press mold, where our company logo, Fereks, appears on the parts of our injection molding machines. Good afternoon, my name is Alexander Marchenko. I'm a foreman of the tool department at Fereks Trading House. We are now in the heat treatment section of the tool department. It is here that the heat treatment of inserts, signs, pushers, counter pushers, glacial plugs, and in general everything that we need for our tool department is made. At the moment, we have a workpiece installed for hardening. Hardening is a type of heat treatment which increases hardness. After hardening, we transfer the workpiece to a tempering furnace. Then, temper it to the required hardness, in accordance with the requirements of the technological process. Later, we measure hardness on a special stationary hardness tester. There are calibration plates by which we first check accuracy of our hardness tester. And then we measure the hardness of the part itself, which comes out after the heat treatment. We take the heat treatment modes from the reference book. Using the reference book, we write a program that is then uploaded into the controller. The heat treatment is carried out according to the program. After heat treatment, we send the part to the mechanical area for finishing. The unsoldering section is an automated line for surface mounting of SMD components. The equipment is fully automated, made in Korea with a capacity of up to 40,000 components per hour. So, how does it work? We use components such as Japanese-made Nichia diodes, Japanese-made connectors, and other components made in Taiwan and Korea. All purchased components come to us in the form of coils. The coils are charged into feeders. The feeder is charged to the component installer. We purchase our boards. The boards have our Fereks logo as well as the name of the board, by which we determine for which type of luminaire it is used. The boards are installed into the automatic loader, so it is put into a cassette which is installed into the loader, where the circuit boards are automatically fed to the printer. A special solder paste is applied to the printer using a stencil. There are reference points on the board. With these reference points, the component installer can use an infrared camera to monitor the correct installation of the components. Thanks to this, we ensure high accuracy of component placement on the board. There are two component installers, whereby we can increase the processing speed of boards per minute. Then, after installing the components, the board goes into the 7-zone furnace. The furnace heats up to evenly from 170 to 240 degrees, where the soldering mouth is reflowed and all components are soldered onto the board. There is a cooling zone in the last zone of the furnace, where the temperature is maintained at about 200 degrees. After the oven, finished boards are installed on a cassette, where they are manually taken out and placed on a stand for quality control. Quality control is carried out with a special machine, which supplies a certain voltage in order not to spoil the diodes and not spoil the operator's eyesight. This is how we check the operability of all components. Thus, an additional check of the quality of components on soldering and their further storage is carried out. In order to ensure heat dissipation, electrical safety and tightness, we use compound in a number of luminaires. The compound is applied by a compound machine produced in Belarus. It automatically doses two components and mixes them so that the initial mixture becomes vulcanized. To assess the initial setting up of the mixture and control the uniformity of vulcanization at the beginning of each shift, we perform a test application of the compound with a catalyst in ratio of 100:6 into a measuring cup. After half an hour, the operator of the dosing machine evaluates the setting up of the mixture by the film on the surface formation. If the film is formed, the operator proceeds to a bulk filling. Complete vulcanization of the compound is reached in 6 hours. Housings shall not be transferred for assembly before the expiration of the specified time and without quality control of the test sample. A representative of the technical control department visually checks the vulcanization of the compound and cuts the test sample. If the test results are positive, he writes an identification number on the sample and puts it in the closet. He makes an entry in the journal with a decoding of the sample number, the date of the application, the compound and the catalyst batch number, and a conclusion on compliance. The final stage in the production of luminaires is the assembly itself. We are currently assembling street and industrial luminaires. The assembly is carried out entirely manually in compliance with the design documentation for technological process. The luminaire is considered to be assembled after the technical control department carries out a complete check of the luminaire for correct assembly. After the master of the technical control department has accepted the assembled luminaire, it goes to the run-through section, where it is run at different voltages. The run is carried out in three types of voltage: low voltage, 176 volts, normal voltage, 220 volts, and high voltage, 264 volts. The run in one mode lasts for 2 minutes, then it is turned off for 30 seconds, switches to another mode and is run for 2 minutes. Then it is repeated cyclically for up to 30 minutes. During the run, the master of the technical control department visually checks the operability of all luminaires, then makes notes in the journal concerning the luminaire passing the run stage. Then, the luminaire is sent to the packaging section, where it is packed. After the running time is over, 3 luminaires are selected from a certain batch, for example of 100 pieces, and run at the stand, where the insulation resistance for breakdown is checked. If the luminaire's quality conformity check is positive, all the luminaires go to the packaging section, where a conforming tag with a QR code and a unique serial number is attached, indicating technical characteristics of the luminaire. The QR code is scanned with a scanner and the luminaire enters the 1C database, where this luminaire appears, after which it can be set for shipment. Then the luminaire is packed, a certificate is supplied, a corresponding label with a unique serial number is attached to the name of the luminaire, and the same label is attached to the packaging as well. The shipment of luminaire from the finished product warehouse starts with a shipment request, which has a unique QR code and is sent to the storekeeper to assemble the request. The assembling is carried out using such terminals. First of all, with the help of the terminal, a QR code of the request is scanned, which is put into the database of the terminal, and according to this request, the luminaires are already selected by the name and quantity. Therefore, the terminal will not allow to assemble a different type of luminaire or a different amount of units. If there is a shortage, it will notify thereof. In case of the excess, it simply will not allow its scanning. Further, the accompanying documentation is supplied to the scanned order. The order is loaded into the car and shipped to the customer. All products manufactured in the town of Laisheva are sent to this warehouse every day, and all products manufactured in Stalbisha village at each of the shops comes here as well, and here general orders are formed and shipped to the customer. We are now at the second Fereks production site in the town of Laisheva, 50 kilometers from the city of Kazan. The site has been operating since 2013. The total area is 3 hectares. As of the date, area of operating production facilities is 6,000 square meters. 1,400 square meters of production facilities were built and commissioned in 2016. Additional 1,400 square meters were commissioned back in 2018. 2 shops are under construction now. A continuous process of assembling LED luminaires is organized in the first shop. It is here that the components, profile and PCB are transformed into LED luminaire, which goes through several stages before reaching the end customer, namely assembly, run-through, network simulator, packaging and transportation. We use optics for setting the correct scattering angle of our luminaires. Optics is developed and designed in our design and engineering department and manufactured in our production facilities. For optics manufacturing, 2 thermoplastic automatic machines are used. They differ in force. We use Korean-made material of polymethyl methacrylate produced by LG. The raw material is loaded into desiccant hopper. Then, it is heated up to a pour point of 250 degrees and applied into a press mold. The press mold defines a specific geometry, where the current polymethyl methacrylate fills all cavities, filling in the required geometry. The luminaire is assembled from the obtained finished part. This luminaire is sent to the laboratory to determine the lighting parameters. After the measurements, the lighting engineer gives his conclusion on the possibility of using these optics. After the measurements, the lighting engineer gives his conclusion on the possibility of using these optics. And only after his conclusion, the main batch is launched. In addition to optics, we use thermoplastic machines also for manufacturing various kinds of brackets and plugs. They are made of polycarbonate. The polycarbonate pipe extrusion line is presented here. The material is UV-stabilized polycarbonate. The diameter of the produced pipes varies from 40 to 150 mm. We visited two production sites of the Fereks plant in the village of Stalbiще and the town of Laishevo. Our company is open for cooperation. We will be happy to offer you our products, guaranteeing their reliability and a high level of service. Let's make this world a brighter place together. Fereks, everyone deserves good light.